Good afternoon, class. Today we will continue our lesson on topic electricity. This is the last part on topic electricity. We call it the practical electricity. So in your notes, before I explain the content of your notes about practical electricity, I will use my slide PowerPoint to explain by using my PowerPoint slide. I do attach together with the PowerPoint file in your Dropbox. If anyone interested, you want to print out or you want to study through the PowerPoint, you want to have the file, you just save it. Okay, so first we will do through this PowerPoint, and then after that I will go through your notes on practical electricity. Alright, let's start. So practical electricity. So what is a practical electricity? In this topic, there are two parts that you need to understand. Number one is electrical energy, and number two is electrical power. So in this topic, they will be talking, they will be calculating, they will explaining about how appliance use energy in terms of electrical energy, not heat energy, not other type of energy, but at first it is using electrical energy. Okay, and the term word energy here and power here, they are totally different. In this, there are two parts here, that's why I separated into two parts. And then, so what is the electrical energy? Electrical energy is a very simple, you have learned this one before. Basically it's just energy with a symbol of joules, with symbol of E, capital letter E, and then the unit will be joules. Okay, whereas power, or known as electrical power, will be symbol as capital letter P, where the unit will be in watt, W-A-T-T, and then also known as joules per second. Okay, also known as joules per second. So example, let's take an example. If we have electrical power of 10 watt, what does it means? 10 watt means 10 joules of electrical energy used every 1 second. So that is what it means. So we know that many appliances, for example, we have 100, for example, like TV, 115 watt, kettle, 2300 watt. Okay, and then we have, and then we have a fan, 45 watt, we have stereo radio, 92 watt, and then we have air conditioner, 2 horsepower. So with this amount of power, we do understand that what does they means. For example, 115 watt is also known as 115, if we use this context, 115 joules of energy used in every 1 second. Okay, so among all these 5 appliances, which one do you think use large amount of electrical energy in 1 day? Not talking about 1 second, in 1 day. So some of you might think about, macam mana boleh aircon ani 2 horsepower? What is the rating of horsepower to watt? So there's a conversion over here. 1 horsepower, let me check this one. Okay, 1 horsepower is equivalent to, sorry about that part. Okay, 1 horsepower equivalent to 750 watt. 750 watt. 1 horsepower. So 2 horsepower will have 1500 watt. So all these 5 appliances, you will notice that this kettle will use 2300 joules of energy in 1 second. So this is the highest one energy. Okay. And then we have fan, we have radio, we have air conditioner. However, the amount of energy used in one day, yang paling banyak makan karan, use karan, electricity, will be the air conditioner. Why? The air conditioner is used, some of you at home, you switch on the air conditioner 24 hours. But the kettle, you only use it for couples of minutes. Even though the power is high, but the usage is only short period of time. So in terms of long period of time, the air conditioner will use large amount of electrical energy. Right? Next one, the relationship between power and energy. So we have this formula P is equal to E over T. So that is the power energy divided by time. Okay. So that is the formula that you will use, which you have learned before. Another formula that I include over here is E is equal to QV, which already you have learned before through potential difference and EMF. And then there is another formula here, E is equal to VIT, voltage time current times. Okay. Now the other two here, don't worry about these two. Don't worry about these two. It's actually the combination of these two formula. Oh, by the way, there's one more formula over here. There's supposed to be V is equal to IR. Okay, you learned this one before. So the formula for electrical power is P is equal to IV. So in this topic, the formula that is important that you need to remember, the basic one is this one, 1, 2, and 3, and 4. Ani saja, 4 ani saja that you have to remember. The one at the bottom 4 atau is actually the combination. It's actually the combination of this formula, some of them. Okay. Now, such as, I'll give you an example. Some of you might be banarkah, apakah. So, it's actually the combination. Let me show you. Okay. Oh no. Can I insert new slide? Okay. So, let's say about this one. Okay. Now, this is the basic formula. P is equal to IV. V is equal to IR. I can substitute this V into this over here. So when I combine this formula VPI times, after it's been substituted, it will become I times R. So the formula will become P is equal to I square R. So that is how we get the formula over here. Ano tadi tu? I square R. Okay. So actually it's just a combination. But don't worry about that part. The most important thing is the basic formula. So let's take an example. An electric iron is labeled 240 volt, 1 kilowatt, and then it's under normal working condition. Find the resistance of the heating element. Okay. So let me check this one for a while. Sorry about that part. Sorry guys, just for a while teaching PowerPoint. Yeah. Okay, never mind now. Let's continue. Okay, so for example, this one at the resistance of the heating element of the iron. So basically use the formula V is equal to IR. Okay, no, sorry, P. Can I put some formula over here? So don't worry about example, just move on. The next one is the measuring electricity consumption. So nowadays we don't have this kind of meter, unless you guys remember a long time ago we do have this meter installed every houses. This is what we call the electricity meter. Nowadays we use the prepaid meter. Okay, we use the digital one, prepaid meter. Long time ago we used this kind of a meter. All right, and if you notice over here we have a particular unit, they call it the kWh, kilowatt hour, which I will explain after this. So the electrical energy is sold in units of kilowatt hour, K, capital letter W, and H. So if we use 1 kilowatt hour, how much energy is actually we are using? Okay, normally kalau tanya ada electrical appliance, when we calculate, the answer is in joules, right? Joules in energy, berapa banyak energy tadi pakai. But if we use 1 kilowatt hour, it's actually 1 kilowatt times 1 hour, you times become 1000 wattnya, and then hour becomes second, 3000, and then this is the amount of energy that we use, that 1 kilowatt hour, 3,600,000 joules. That's why this meter, the number will rotate every time you rotate 1 kilowatt hour, increase in 1 kilowatt hour, meaning the whole house, kamu punya house satu, you are using 3,600,000 joules, 600,000 joules of energy sudah. Okay, so basically the kilowatt hour is just a unit for electrical energy. Pasal atu sanang dikira, sanang dilihat. Okay, so we have an example over here. If 1 kilowatt hour of electrical energy costs 18 cents, how much will it cost to operate 250 watt of electric iron for 4 hours? So if we use the formula E is equal to P times T, we substitute 450 watt, 4 hours. We need to convert into kilowatt class. It is very important to convert into kilowatt. And then after that, once you times, then you become 3, the unit kWh. So this is the amount of electrical energy that you use for 4 hours, and then after that you cross multiply. 1 kilowatt hour costs 18 cents. If 3 kilowatt hour, how many you use? So after you cross multiply, so the answer is 54 cents in 4 hours. Okay, so this is how much of electric iron that you use for 4 hours. Now it seems very cheap. Some of you might, oh, murah je 54 cents. But technically, if you use this amount of electrical energy per day, you times it with 1 month, 30 days, now you will see how much that only one appliance costs. Next example. A light bulb is labeled 240 volt and 0.3 ampere. How many joules of electrical energy are changed to thermal and light energy if the bulb is switched on for 30 days? And also calculate how much it costs for 1 kilowatt hour for 20 cents. So we need to calculate how much electrical power they use. After they calculate, it becomes 72 watt. And then after you calculate how much energy you use, it will become 51.84 kilowatt hour, and then you cross multiply. Okay, I'll try to make it as simple as possible because we have another notes that we need to cover in your okay, sorry, what I meant here is your notes need to be explained. Next one is dangers of electricity. So electricity is not I know it's very useful for everyday life. It's for our own use. We will be problem if we don't have this electricity. Most people cannot live without electricity. But at the same time, electricity also can be dangerous to everybody. There are two major dangers when using electricity. Number one will be it will cause electric shock. It can cause people to get electric shock, a person, and also can cause fire. Alright, these two things will be the factor will be caused by electricity. Now this danger can be caused by, number one is damaged insulation. Wire-nya rusak sudah, open, rusak. So you will notice that di sana the brown color itu is actually the copper wire. That is a copper wire. It's a live wire. Bila kamu pegang, kamu dapat electric shock. Number two is overheating of cables. Now in this case, socket is not recommended to plug in 3, 4, 5 appliances at one time. It will heat up the socket, and then once you melt, and then the temperature increase. As a result, as the temperature increase, the fire will ignite. So this is what we call the overheating of cable. Damp conditions. Water is a good conductor of electricity. So what happens when electricity pass through the water? As a person walks or touch the water, they can get electric shock. So some of the current is just, for example, like 1 milliampere, it will be no pain at all. But if you have 5 milliampere, it will be harmless shock. Higher than that, 20 milliampere, it can cause your muscle to contract, uncontrolled muscular contraction, and loss of muscle control. You cannot let go. If you have 50 milliampere, it can cause pain, exhaustion, breathing affected. Probably people like the police use this one as a stun gun. Next one will be higher, 300 milliampere. It can cause uncoordinated contraction of the heart, leading to death. Okay, so that is the danger of electricity. Safety electricity. There are few steps, precautions that we need to take when we use electricity. Number one, we need to install fuse. Most appliances, they have a fuse in their device or normally in their plug. A fuse is safety device which is made out of a piece of thin coated copper wire. The use of fuse is to protect the appliance from overflow of current. This is a very important understanding. The use of a fuse is to protect the appliance from overflow of current. Okay, when there is a overflow of current, the fuse will melt. This is very important. It will melt and breaks. This will cause open circuit. Okay, so that is the use of fuse. This is a sample of fuse. So we have a 3 ampere fuse, we have 5 ampere fuse, we have 13 ampere fuse. Okay, Those are the rating. We call it the rating of the fuse rating. Now what they meant here is a fuse is made up of a piece of thin coated copper wire. Is this one, the line over here, the small thin piece of wire. You know what happened a wire, if you hit pass large amount of current, they will heat up, and then when you do overflow, when there is overflow of current, the wire will heat up and then burn and then melt and then breaks. Normally fuse installed slightly higher than the maximum current used by the device. Okay, for example, if the device operates 3 ampere, you use 5 ampere fuse. If the device use 2 ampere, kamu pasang 3 ampere, slightly higher. For example, calculate the current taken by an 800 watt vacuum cleaner connected to 240 volt supply. Suggest a suitable rating for the fuse to be used to prevent this vacuum cleaner from overheating. By using formula I is equal to P over V, comes from P is equal to IV. After you substitute, you can get the current here. So this is the current used by the vacuum. So the fuse that you use to put arah plug slightly higher should be 5 ampere. You don't put 4 dada. There are 3, 5, 13. If I'm not mistaken, ada 10. Okay. Number 2 is another safety features is what we call the earth leakage circuit breakers, or known as the ELCB. You can find this one arah circuit board, arah houses, arah sekolah pun ada juga. Okay, some if your parents use this term, or kalau ada ribut, okay, ataupun tanda trip, meaning the switch terturun. Apa maksud terturun itu? This is the one, ELCB ni, ia punya switchnya terturun itu maksudnya ia trip, terturun ke bawah. So all you need to do is just push it up, naikkan ke atas. The use of circuit breaker is to cut off the electric current when high current flow through the circuit. So the circuit breaker is like a fuse lah juga. Agaknya ia dapat pakai balik. But the fuse, once ia putus, you have to replace it, buy a new one. Number 3 is switch. Switch ini very simple. People don't notice that switch ini is part of the safety device. Switch is long time ago sudah ia kena invent. The purpose of switch is a safety purpose. Switch is to turn on and or off electrical appliance. Okay, it's a very simple concept. The next one is earth wire. There are 3 types of connected in the circuit. Live wire, brown color. Number 2, neutral wire, which is blue. Number 3, earth wire, yellow and green stripes. This is the sample. The blue, neutral wire. The brown here, live wire. And then we have a earth wire, green and yellow stripes. And here is the fuse that connected arah live wire. Fuse must be connected to the live wire. Okay. So the earth wire is connected to the metal casing. This is very important. Earth wire is connected to the metal casing of the appliance. Why? The reason earth wire is used, the earth wire, if there is any fault on the appliance, kiranya ada faulty arah appliance atau, the earth wire will protect the user from getting electric shock. That is the purpose. I will explain in detail in pakai notes arah PDF kamu, PDF file or your notes paper kamu. Okay. So last part from this slide. Make sure you know the diagram of the socket, the location, the position of the earth wire, live wire, neutral wire, and then fuse. Okay, so this is a 3-pin plug. So now let's move on to your notes. Alright, we need to move on to your notes. Oh, sorry about not this one. Alright, now your notes. I know you from the slide itself you give you some idea what is practical electricity. So in this topic from your notes I will explain a little bit faster. In this section you'll be considering the use of electricity in our homes. When an electrical appliance is used, electrical energy is changed into other forms of energy. Okay, for the following appliance, state the energy change that take place. For example, the light bulb. What is the energy change there? From where to where? Of course, yes, start from electrical energy to light and heat. Okay, those is the energy conversion. Hair dryer, of course, it comes from electrical energy, and then it will become heat energy and kinetic energy, and also sound energy. Electric kettle, electrical energy to heat energy. Oh yeah, basically it's just heat energy. Yeah? So next one. So the formula for electrical energy, they start here with the power. Power is defined as the rate at which energy is released. So the formula for power here is P is equal to IV. Okay, so P is a power, whereas the unit is in joule. Power is watt. Sorry, watt. Capital letter W. Okay, and from my slide I did mention about watt itself is also known as joules per second. Next one is I is the current, which is the unit is in ampere, is capital letter A, and V is the voltage, which is the volt, the unit is capital letter V. Alright, note other common units are 1 milliwatt is 1/1000th of a watt, or 1 kilowatt, 1000 watt is known as 1000 watt. This is normally used, very famous, and 1 megawatt is 1 million watt. This equation often used with the resistance V is equal to IR. So this is the formula, V is equal to IR. Okay. So here is some examples. Very often electrical components have the power stated on them. Okay, what does it mean if you have a bulb has stated 60 watt for 240 volt? Now class, why voltage-nya selalu 240 volt? Every houses or electrical power station or the transformer that deliver to houses, semua soket yang tani plug in atau semua bagi 240 volt. Okay, all appliance pakai 240 volt. Okay, and then we have 60 watt bulb. How much is what does it mean the bulb has stated 60 watt 240 volt? Okay, means 60 watt. Sorry, let me change this one a bit. 60 watt means 60 joules of energy used in 1 second. Okay, What will be the current flowing through such a bulb? You use the formula P is equal to IV. The power is 60. The voltage is 240. Okay, so the current will be something ampere. So it is 60 divided by 240. 6 1 over 4 is 0.25. So question number 3. So what I want you to do here, we have a slot over here. What I want you to do is to complete by using your calculator and by using the formula given. Okay, and then let's move on. Electrical energy. So the relationship between electrical power and electrical energy is power is equal to energy over time, or based on my previous slide, electrical power is equal to electrical energy divided by time. So this is E energy, which is in joules, P is power, which is watt, T is time in second. Okay, and then the formula can be used as E is equal to VIT. Alright, and so on. You can put in over here energy, voltage, current, and time, the unit. I know you guys can do it. So next slide. Next, what is the energy used by the 100 watt switch on for 50 minutes? Okay, so by using the formula P is equal to E over T, or by arranging it, E is equal to PT. The power is 100 times 50 minutes. Now we don't want to have in minute, we need to have in second if we want to find electrical energy in joules. So this one will be 100 times 50 times 60 to become second. So the answer will be 1 2 3 4 1 2 3 4 5 joules. 1 2 3 4, oh no, one more zero, so 300,000 joules. As you can see from the example, the joules is a small unit to measure electricity with. For home, usually we use another unit. We use it in kilowatt hour. Okay, kilowatt hour, HOUR. Okay, kilowatt hour. 1 kilowatt hour of energy is the electrical energy by a 1 kilowatt appliance in 1 hour. This is often referred as a unit of electricity. Class. Last year I teach you guys electricity, energy. I did mention that the time must be in second kan. The time always is in second. All other topics dalam physics, time must be in second. Only this topic saja, this particular topic ani saja, there is only one time. The time is calculated in hour. Mesti hour. Mesti hour. Ingatkan tu ah. Why? It's because of this unit, kilowatt hour ni. That's why we need to use hour. Alright, let's take an example. There are a few things here that you need to fill in. For example, I'll give you some example. Let's say the aircon. How much electrical energy in kilowatt hour? Use E is equal to PT. The power is 1500 watt. Let me give you guys a full screen over here. Okay. E is equal to PT. Power 1500 watt times the time is in 8 hours. Now if you times directly, the unit will become WH only, watt hour, but we want to have kilowatt, so we have to change this one to kilo. It will be divided by 1000, so it become 1.5 kilowatt times 8 hours, so you will get the answer in kilowatt hour. So 5 become 4, 4, 8, 12, 12 kilowatt. So that is how you calculate to become kilowatt hour. So what you need to do is fill in this data, calculate using your formula and then your calculator. Next one, the cost of electricity. Electricity is bought from the PUB by the unit of kilowatt hour. So what is a PUB? I don't know what is a PUB. What is a PUB? I never heard PUB before. Let's Google. Let's Google. Electrical PUB. What is a PUB? PUB means in electricity, power bar, yeah, this is the one, Public Utilities Board. I think that is the one. Okay, but never mind lah, it's not really that important. So the Public Unit Board is by the unit of kilowatt hour. So what is the cost of running 2 kilowatt air conditioner from 9 p.m. to 7 a.m. if the cost of electricity is 15 cents per unit? Okay, so let's go through here. First, all we need to do is to find how long it takes to use the how long it use the they use the air conditioner from 9 p.m. to 7 a.m. So here 9 p.m. to 7 a.m. from 9 to 12, 9, 10, 1 hour, 10, 11, 12, 3 hours sudah, 3 hours, and then from 12 to 7 is 7 hours, so technically here is 10 hours. Okay, so all you need to do is use the formula E is equal to PT. So the power is 2 kilowatt times 10 hours, you get 20 kWh. Okay, and then by using cross multiplication, which is the cross multiplication, if you have 1 kWh, will give you cost 15 cents, 0.15 dollar sign. If you have 20 kWh, it will give you X, cross multiply X will give you let me guess, ini pindah ke sebelah, is it $3? Yeah, $3 if I'm not mistaken, so become $3, so it's $3. Okay, and then question number 2, a 2 kilowatt kettle used 3 cents of electrical energy in boiling some water in 5 minutes. What is the cost of kilowatt hour of electricity? Okay, apa ni? What is the cost of kilowatt hour of electricity? Oh, okay, seems like a bit tricky, but I will help you guys. It says that we have to calculate so E is equal to PT, 2 kWh times 5 minutes. And of course, the 5 minute itself, we need to change to hour. So you divide by 60 to become hour. So divide by 60, the answer will be 1/6. Berapa tu 1/6? Calculator. 1 divided by 6. Oh no, 0.167 kilowatt. 0, never mind lah. 1/6 kWh. Okay, 1/6 kWh. It says that it used 1/6 kWh only for 3 cent. 3 sen saja. What is the cost of electrical energy if you have 1 kWh? Will give x how many cents? So cross multiply. So x will become times 1/. So 3 cent times 1/6. So x will give you 3 times 6 will give you 18. So 18 cents. So that is the answer, 18 cents. Okay. Next one, electricity in the home. The electricity supply to our homes comes from the PUB again and will pass through the electricity meter and the main switch and then to your circuits in the house. There are several circuits, usually like one for lighting, one or more for power socket, one for the cooker, one for the water immersion heater. Each circuit has its own fuse. Okay, so this is an example. Most of the circuits have 3 wires: live, neutral, and earth. Alright, now this node is totally different from much kind of big difference compared to my slide. My slide is very simple, but I think it's easy to understand. But his nodes is a little bit complicated, but some of them are very useful juga. So you will notice there are many sockets over here. The one that I need to explain over here is this part. Class. The fuse and the switch, kalau kamu lihat di sini, must be connected arah live wire. Mesti tu, must be connected arah live wire. The fuse and the switch. The power circuit contains 3 rings of wire connected parallel to each power socket. Hence, it's often to ring main. Don't worry about that part. Don't worry about this one. Not really that important. So we have a 3-pin plug. We did explain over here what are the correct colors for the 3 wires found in the 3-pin plug, and then and give their correct colors. Alright, so this one is earth, green and yellow. This one is live, which is brown, and of course this one is neutral, and of course blue. And this single device here is the fuse. Which wire is connected? Is the fuse connected to? It is the live wire. Okay. Switches. Used to turn on and off electrical appliances. Consider the following case of the fault of the appliance. You will notice here, okay, let's enlarge the diagram. Alright. Now, as you can see here, there are two diagrams, figure 1 and figure 2. Okay, number 1, this one, no electric shock. This diagram, the first one, this person ada electric shock, large current flowing to the person, they got electric shock. Pasal apa? What is the difference between these two diagrams? Okay, I will show you the clue here. This is the switch here, and then the switch over here. Okay, now I did mention just now, the switch and the fuse must be connected arah live wire. Why? This is the reason why. Current datang dari live wire, ia akan jalan kemari. So even though this one is open, ini masih open, the current boleh berjalan arah sini. It can still move somewhere here if this thing ada faulty. So since di sini jadi live, the person yang pegang pun currentnya akan lari and goes to the earth. So the person will get electric shock. Alright. However, for the second diagram, since the current ani lalu arah fuse, since ia open switch, ia tidak dapat lalu ke sebelah. So anytime someone touching the device, even though you switch off, ia tidak dapat electric shock. Okay, so that's the reason between those two diagrams. Is it safer to place the switch in the live wire or the neutral wire? Okay, the answer is live wire. Because, okay, when the switch is open, it cuts the current flow from the appliance. Okay, cuts the current flow from the appliance. Next one, fuse. Name the two different types of fuse pictured below in our home. Here is what we call the fuse. This one, yeah, this is also type of fuse ni, but this one is used arah circuit breaker, arah circuit board. Okay, so what is the purpose of having fuse in a circuit? If you refer to my notes, fuse is to protect, to protect the appliance from overflow of current. Okay, is to protect the appliance from overflow of current. How does the fuse works? When there is overflow of current, it melts and breaks, causing open circuit. Alright, so that is how fuse works. Okay, not all fuse are the same. Typical fuse rating, we have 1 ampere, 3 ampere, 5 ampere and 13 ampere. We always choose the fuse to the next highest power rating or slightly higher. If a bulb takes 3.1 ampere, which fuse that you need to use? 3.1 ampere. Slightly higher will be 5 ampere. If the appliance is stated to the power rating 300 watt and is to be used 240 volt, which fuse would you use? Okay, ni dah ada space nya. So we just ignore B pasal ada space. Which wire live neutral would be placed to fuse the best to place the fuse? It will be the live wire. It will be the live wire. Why? Because it is the current flow starts from the live wire. Okay, last one, earthing. Now it is the same diagram. Okay, they kind of a bit different. To complete a circuit, we need only 2 wires, the live and neutral wire. But if something goes wrong with our appliance, then the following may occur. Now let's have a look on this diagram. Technically, every appliance only need 2 wires saja. Earth wire is a special feature saja, is to protect the user from getting electric shock. Macam mana boleh? Now as you can see here, we have a live wire. The fuse is correct, the switch is correct. So the current flow here goes to the motor and go back to the neutral wire. Okay, the current flow. However, sekiranya wire yang ani macam putus, touching arah metal washing machine, macam kena gigit tikus kayak macam worn off ke, and then at the end ia touching to the metal casing of the washing machine or electric kettle. So what happened? The current, instead of going back here, it will flow through the washing machine. So the metal casing at the high voltage due to electrical fault. Electrical fault, live wire comes off the motor and touches the metal casing. Normally they use this term. So the metal casing becomes live. Atau maksudnya ia ada current. So when a person touch the metal casing, and then the current will flow through here, through the body, goes to the person and goes to the ground. So there is a complete path. So this person, he got electric shock. So that's the reason. So di sini ada 2 wire. So what happened there if we have one more wire? We call it the earth wire. The earth wire is one more wire, is connected to the metal casing here. You will notice ini metal casing, you connect, and then goes to the earth. So anytime kalau the live wire touching the metal casing, so the metal casing jadi ada current kan, no? Become live, the current will go to the earth instead going to the person punya badan. So the earth wire connected to the metal casing divert the large current due to electrical fault to the ground. Okay, so the person will not suffer an electric shock as the large current flow through the earth, zero resistance instead of through him. Okay, so that is the reason what happened here. So we use third wire, earth wire, to allow the current to return by a path of low resistance. Don't worry about that part. Which part of appliance must the earth wire to be connected? To the metal casing. Okay, metal casing. The dangers of electricity. Now, electricity flowing through our body will cause electric shock. Starting from higher 1 milliampere, just cause electric shock, or it can cause, if you have 100 milliampere higher than that, it can cause death. The major danger of electricity are damaged insulation of wire, damaged insulation, overloading of wire, which can cause connecting too many plugs in one socket, the wire will heat up, the insulation plastic may melt and causing short circuit, electric shock, and can start fire. And number 3, getting water near to the electricity. Water enables the current to flow or can cause short circuit. In contact with the skin, water will reduce resistance of the skin, meaning that the risk of electrocution will be higher. Don't worry about that part. So water is a good conductor of electricity and person can get electric shock. So that is the last part of the topic electricity. Okay, so I think that's all. I will send you guys exercise on practical electricity next week. I think that's all for today. Thank you.